go through the 2014 final exam for Math 95 as a practice for this year. So I'm going to try to run through it pretty fast, but I'll give the link to, I'll email the PDF so you guys can see the work. The first several problems are just order of operation problems, so remember on this one, multiplication comes first, then you can see the rest. Here we have 2 to the third, which is 8, and we have negative 2 all raised to the third. So that's negative 2 times negative 2 times negative 2, which gives us negative 8. And we're subtracting a negative, so keep that in mind. In this problem, we have a division, so I chose to rewrite it as multiplying the reciprocal, and multiplication comes before subtraction, so we're going to do that part first. So 2/7 times 1/5 gives us 2/35. Then I need, to deal with this subtraction, I have to have a common denominator. So I go ahead and do that, multiply 3 by 7 and multiply 5 by 7 and get this, and goes through there. In this one, remember these straight lines mean absolute value, which means anything that comes out of this has to be positive. So it's like grouping, so we do that first. So we have 2 minus a positive 2, and here we have this negative 2 squared, which means negative 2 times negative 2, which gives us a positive 4. And so we have 2 minus 2, and then plus 4. Remember that when you have subtraction and addition, they're the same level, so you just go left to right. So 2 minus 2, and then plus 4. Alright, for this problem, we have some mixed numbers. So I chose to go ahead and break those apart because 3 and 3/16 means the same as 3 plus 3/16. And then subtracting this, remembering that these are together. So I rewrote that. I distributed the subtraction, so it's minus 1 minus 1/4. And then I just rewrote the whole numbers here and the fractions next to them. So then 3 minus 1 is 2, and then I can do 3/16 minus 1/4, which is the same as 4/16. So I have 2, and then I have a negative 1/16 here. So that means I have 1 and 15/16. Alright, another order of operations problem here. We have inside of parentheses everything except this divided by 10. We have exponents here that has to come first. So 4/10 times 4/10 would be 16/100. So make sure you get the decimal in the right place for 16/100. Then we have the multiplication. So now 16/100 times 100 would be 16. And then we have inside the parentheses still, we have the addition, so we need to do that first, and then divide by 100. Okay, remember dividing by 100 just shifts to two place values. So we have that. The numerator and denominator each kind of function like a grouping system. So things in the numerator have to be done, and then things in the denominator when you're dealing with order of operation. So I have multiplication here, so 2 times negative 5 gives me negative 10. I'm subtracting a negative, so that's the 18. And here I have to do my grouping first, so 4 minus 2 gives me 2, and then times 3. So now I have 18/6, which is 3. And same thing here, I'm doing a very similar, it's kind of a combination between what we did in E and what we did in G. So we find a common denominator, do that grouping first. We find a common denominator this is common denominator in the denominator of the complex fraction and a common denominator in the numerator of the complex fraction. So we use sixths here, and here I use 36ths. So I got 3/6 over 7/36. I went ahead and changed this to multiplying by the reciprocal, and then these 6, you can't see it as well. If you write it out vertically, you'll be able to tell better that the 36 and the 6 have some canceling pieces, so all of this goes to 1. So I could write 3 over 1 here, but I just wrote 3, and then instead of 36 now I'm down to 6/7. So 3 times 6 is 18, so 18/7. Alright, for number 2, we're looking at solving, and so here I'm distributing, Then I put my like terms together to 2x and negative 4x gives me negative 2x. Over here I had this 4 and the 7 give me 11x. Then I'm going to add 2x to both sides to give me 13x on the right side and 0x on the left side. And then I'm adding 10 to both sides to give me 22 on the left and 0 on the right. And then now I can take x and divide it by 13 and take 22 and divide by 13, and I figure out what 1x is. So I have x equals 22 13ths. There's no common factors, so that's as simple as it gets. You could make a mixed number. Improper fraction is fine for me. Alright, and here is as simple as multiplying by the reciprocal. So I have 24 times negative 11 fourths. I went ahead and did, to keep my number smaller, I did 24 divided by 4 first, and I got 6, and then 6 times negative 11 to give me negative 66. Alright, in this one, very similar. I'm adding, remember when you're solving equations, it's like doing the order of operations backwards. So I'm adding 23 hundredths to both sides, so I get 1 and 44 hundredths. Then I have 1.2 times x, so I'm going to divide by 1.2 on both sides, and I get x equals 1.2. That's kind of like 144 divided by 12 would give me 12, and then my decimal point is. And you can always check that by taking what you get here, that's your x, so 1.2 times 1.2, and make sure you come back to that. So just be careful when you're doing your division to keep track of your place value and where your decimal point is, and remember what's reasonable, right? This is close to 1, this is close to 1, so your answer has to be close to 1 as well, because 1 times 1 is 1. Alright, for this one, we're just rewriting. We have 30%, so I said 30% per 100 divided by 100 of, so times what number, so x, is or equals 2/5. And so I went ahead and multiplied by the reciprocal on both sides. That gives me 1 times x, which is x on the left, and then I have 2/5 times 100 over 30. 100 over 5, if you wrote that vertically, you would be able to tell we also have 100 over 5. That's 20. And then if I take 2 from 30, I get 1 here and I get 15 here, so I have 20/15ths, which I can then reduce to 4/3. When you have everything multiplied and divided like that, sometimes it's nice to do the simplifying first if you can. Of course, I could also do 10/3 here instead of 130ths and go through that same process. Alright, on number 3, multiplying, I like to write it out as a box. Like I might put this on top, and then down the side I put w plus 4, and then that means I'm going to have 4 boxes. 1, 2, 3, 4, and then after that I just combine like terms. This thing here just means raised to the power of 2. So that's pretty straightforward. You're multiplying each term in the first by the term in the second. This is the same problem, different numbers, but this square just means you're multiplying a second time like this. Everything inside the parentheses gets twice. So we do the same thing. We'll multiply the first ones. So we have 9w squared, and then negative 3w, and then another negative 3w from here, 1 here, and then 1 there. And then the plus 1 from negative 1 times negative 1 gives us positive 1. And then I'm just combining like terms. Okay, so remember this, when you're squaring, you get this kind of middle term is going to happen. That's going to be important later to remember. All right, and just like we did in this one where we distributed through this, we did a double distribution here. Here we have a monomial times a binomial, so we'll just distribute this times the first term, then times the second term. So negative 2 times 3 gives us negative 6. A squared times a to the fourth gives us a to the sixth, b times b squared gives us b to the third, and then we have a negative times a negative, so we have positive. 2 times 5 is 10, a squared, a to the third gives us a to the fifth, b, and then no more b's here, so we have a b, and then we don't have any c's, and we have c to the seventh, so we keep our c to the seventh there. All right, in this one, we're not multiplying, we're actually subtracting this too. So once we kind of distribute that negative, we have negative 6y squared and negative times negative, so positive xy. So then we're putting our pieces together. There are no other like terms for x squared, so we just have 3x squared. Then we have a negative 2xy, and then since that one makes a positive xy, we have negative 2 plus 1, so we have negative 1 xy. We can just write negative xy. And then we have our y squared minus, so 10y squared minus 6y squared, so we have 4y squared. All right. Flagpole problem number 4. I like to start, so I'm setting a proportion because I have similar triangles happening here. So I'm setting up a proportion. I like to start with what I'm looking for. So how tall is the tower? So my x is how tall the tower is, and then my 10 is how long the shadow is. So I've got height over shadow for the tower, so I've got height over shadow for the flagpole, so that's 10 to 3 again, or sorry, 12 to 3 for that. And then all I have to do is multiply by 10 because I have x divided by 10, so I multiply both sides by 10, and I've got that. 12 thirds is just 4, so 4 times 10, and I've got 40, in this case feet, 40 feet. All right, when you have this salary and commission, just remember that the total equals the base plus the commission times the sales. So our commission here is 4%, so 4 hundredths times S, and I have 1,800 base salary, and total salary was 3,720. So I'm subtracting 1,800 on both sides. I get 19 that. Then I'm multiplying by the reciprocal, so 100 over 4. So I did that. I went ahead and reduced 100 over 4 to 25. So I have 25 times 1920, which is 48,000. So my total sales were $48,000. All right, next one, we've got a right triangle, and we're given the hypotenuse in one leg, and we have to find the other. So we have our a squared plus b squared equals c squared. Hypotenuse is the c, so that's the 17 squared, which is 289. 15 squared is 225. So that tells me that a squared is equal to 64. So a, taking the square root, must be 8. And because you don't have a calculator, you can assume that these are going to be nice, neat square numbers here if you see a problem like that. All right, for this one we have a percent increase. So we're dealing with how big a pizza is. We're looking for the amount of pizza. So that's going to be the area of the pizza, and we're given the diameters. So to change from the regular diameter to the regular area, I have half the diameter, which is 5, and then square that, so 25 times pi. So I have 25 pi, and for the large, then half of 12 is 6, square that is 36. So I'm looking for the increase, so I'm looking for the difference divided by the original. So 36 pi minus 25 pi divided by the 25 pi equals what percent? That's what I'm trying to figure out. Well, that's 11 pi over 25 pi, or 11 over 25, and that equals x over 100. Now you could notice that 25 is times 4 gets us to 100, so I could say 11 times 4 gets me to 44. Or you could go through the process of multiplying both sides by 100 and then going from there. So this would be 44%. All right, for number 5, we're graphing. So like I said, especially when you have a situation like this, putting a 0 in is nice. So when I have x equals 0, then I solve for y, and goes through this process, pretty straightforward. 2 times 0 is 0, so that drops out, and then I divide, and I get an ordered pair 0, -6. You might write it in there just to be nice and neat for me. And you can do a similar thing with the y. You put a 0 in for y, that term drops out. So you have 2x equals 30, so x must be 15. And remember that you put in the 0 for the y, so that's over here, and the x is the 15. Okay, now once you have 2 points, you can draw your line. Remember that the x is this way, you even have an x here, and the y is this way, vertically, so you got your y here. So 0, -6, it's going to be here. 15, 0 is going to be over here, and you can draw your line across there. And then, of course, that's going to show you where some key points are, but you're going to need to do the math out for that, do the arithmetic. So, for example, I saw that 5 looks nice and neat, and that makes sense because if I'm trying to figure out y, I'm going to have to divide by 5 at the end. So I chose x to be 5, so I got 2 times 5 is 10. So I subtracted 10 from both sides, and that gave me 20 here. So I had -5, y equals 20, and so y must be -4. So I did 5, -4, and of course that fits on my line too. All right, and here we have a few more problems. This is right as its prime factors. Well, I knew that 72 was 8 times 9. At least I think it is. Yeah. And so I did 8 times 9, and then I said, well, I know that 8 is 2 times 2 times 2, or 2 cubed, and I know 9 is 3 times 3, or 3 squared. So I have 2 cubed times 3 squared for my prime factor. All right, greatest common factor, here I did the same thing. I said 60 is 6 times 10, 6 is 2 times 3, 10 is 2 times 5, so I have 2 times 2, or 2 squared, times 3 times 5. And here I knew that 75 was 3 times 25, and then so 3 times 5 times 5. So I say, okay, well, how many do they have in common? They have a 3 in common, they have 1 5 in common, so that's 3 times 5. So 15 is the greatest common factor. All right, here, writing this as a percentage, I have 3/20 equals what percent, basically, what divided by 100. So a couple ways I can do this. I could say, oh, well, I know that 20 to 100 is 20 times 5, so I could take the 3 times 5, and that gives me 15, so I know that. Or I could start from that again and say, okay, well, that's x divided by 100, so I'm going to multiply by 100. So that's 3/20, or 30 halves. Well, 30 halves is 15. Right, here I'm rounding to the nearest thousandth with that th on the end. So that's tenths, hundredths, thousandths, so that's the 3. So my two options are either going to be 1.203 or 1.204, and I have to look at what's behind it and say, okay, that 55, that makes it closer to the 4, so it's beyond halfway. So that's 1 and 204 thousandths. All right, then you have some true falses here. If you're going to use this method where you plug in some numbers, I would recommend avoiding 0 and 1. Don't use 0 and 1 to plug in. They're a bit too, I would say use things like 2, 3, 5, prime numbers that are low that you can kind of work with. Okay, we talked about this problem before. When you have a square, it's not just squaring the first one, squaring the second one, like that says. You actually get a middle term here, right? And we can see that if I put 2 plus 3 squared, well, that's 25, because that's 5 squared, 25. But 2 squared plus 3 squared is 4 plus 9, which is only 13, right? So those are not the same. And you can go through the process of trying these out. I would recommend, for example, on this one, try it out. Put a few numbers in, see what happens, if they're equal or not. This one is one of the rules that we've been using, that we used up above, that when you have a base raised to some power times that same base, that, oh, sorry, I actually messed that up. That is actually false. That should be a plus. If this were true, you'd have x raised to the a plus b. So glad I caught that. Okay, because say you have 2 to the 3rd times 2 to the 5th well, that's 2 times 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 2. So all together that would be 8 of them. But that would have told us that we should add 15 of them. So we know that's wrong. Okay, this one is a times the x plus a times the y. That's just what we would expect. This one, you don't distribute when you're multiplying because they're multiplied through, and you could check that with some practice numbers there. This one is almost right, except it forgot to square the 3, because you have 3x squared y times 3x squared y, so you'd have 3 times 3, so this should be a 9. And then, of course, clearly 2/3 is not equal to some number in the 100,000s. All right, which one's greater? Well, this one is in the thousandths, this one is in the hundredths, so of course that's going to be bigger. Here we have negative numbers, so just remember that if it's more negative, it's actually a smaller number. So our less negative number is greater. Here you can multiply that out, or notice that 2,000 is double, so if they were equal, this one would have to be half of this, but doubling this we get 2, 4, 6, right? So this one's bigger because it's 2, 5, 3 instead of 2, 4, 6. All right, and for this one, I said, okay, well, if I see 4, I see 8. If I double this, make that 8/14. Well, 8/14 is greater than 8/15 because I'm using fewer pieces, so each piece is bigger. So if I have 8 of them, if I have 8/14, they're bigger than, each piece is bigger than the 15th pieces. And so if I have the same amount, then my 8/14 is bigger. All right, and lastly, looking at area, I went ahead and did perimeter also, but for the area, here we're assuming that these tops kind of go the same way and that all these are right angles. So two ways to do this. One is to say, maybe take something like this little chunk here, this little chunk here, and then all this down here, which is what I did here. Of course, you could also kind of make them vertical lines there and take this piece, and this piece. Or another style would be take the whole thing and then subtract out this part that's not part of the area, which is what we did here. And I think I got 9 7/10 square feet. Okay, for perimeter, of course. Here, what I was noting is that I have 1 plus 2 plus 1.1. That's these top pieces here. And then, of course, that's going to also fill up the bottom, so that's why I did 2 times that. I did 2 times 3 to say the right and the left. And then that leaves me with these 2 little pieces here. And that gives me all the perimeter going all the way around, and that would be in feet, right? Okay. And actually, lastly, sorry, it's just rewriting the sentence and solving. So 12 times a number, so 12 times a number that I don't know is equal to, well, that's easy enough, the product of, okay, the product of two things, 4 and, okay, so 4 times the sum, so 4 times the sum, so I'm going to put parentheses, so 4 times the sum, the number, and 3, so the number which I used x for, and 3. And then we can see how we distribute that. Subtract 4 on both sides, 4x on both sides, we get 8x, and then I divide by 8, I get 12/8, and I reduce that to 3/2. Okay, so I hope that was helpful, and I'll see you